Hello and welcome to lecture 4 of Introduction to Philosophy of Science. This is the second lecture in the series of IDCE, that is Induction, Deduction, Confirmation and Explanatory Inferences. So given that understanding, and we will start from where we left in the last lecture, that we had a very basic idea of what is induction and how it is different from deduction. In fact, we discussed about deduction first, and after that we started with induction. Now, I was in the first lecture as well, was telling you that there is a perennial problem with induction, and that is what we call as the problem of induction. The problem of induction, or this terminology, is basically accredited to a British philosopher called David Hume, and it roughly speaks about that there is absolutely no guarantee the way things have happened in past, the way things will happen also in future, right? Because what is the role of science? If you understand, the role of science somewhere down the line is also about how to predict future, right? Because it's not the work of astrologers only to predict something. The work or the goal of science also is to have a way, or we draw a line, or we draw the curve, that how it is going to follow, or how it is going to say go from one place to another place. So given that understanding of prediction, we are never sure, and this is the biggest problem with induction, that irrespective of the fact that so many things have actually confirmed an observation or a theory, there is absolutely no guarantee that you can reach the same thing again, because it may change at some point of the time. And as we say in deduction, that one bad line is enough to prove that an argument is going to be invalid. Similarly, one observation can also prove your generalization a wrong generalization or an incorrect generalization. So this is basically in the nutshell the problem of induction, and we need not delve much over here and spend some time. Rather, we will come to certain topics, certain new things which we will be taking in terms of induction. Now, induction can have, or induction is is having a lot of I will say names or something. So we will talk about it. But before that, induction sometimes also is understood as projection. So, like as I say, that prediction is one way of understanding the course of science. Similarly, projection is also one of the ways of understanding what is induction. Because what induction does, induction basically projects that this is how things will happen, or this is how a generalization can take place. Because if you see that we have number of observations like this, right? So if we have number of observations like this, so we think that the next number will also follow this sequence, right? Or it will also have the same kind of observations, or the same kind of things which we have thought about in these cases will also be projected in the next case. So that kind of understanding is also induction. So as I told you, and why induction is going to be very important, because if I give you one more example, you will have a better idea. Like, we say that deductive logic is the least, I will say, controversial form of logic. Induction, or say nowadays, these days, you can also call it like the genre of non-deductive logics. So all the non-deductive logic have more, I will say, controversies surrounding, or at least this is how the deductive logician will perceive it. Deductive logic is, on the other hand, less controversial, very, very less controversial. This is the understanding. This is how they take it. Now, let us come to our last example only and see the argument again. When I said all swans are white, if I take this example again, and I'm not taking the rest of the two things, just concentrating on this premise or just concentrating on this statement. So, and we say that suppose it is a true premise, or if it is a true statement. Now, there is absolutely no way in which a deductive logician can come with this generalization. This is basically a result of inductive generalization. The result of inductive generalization is used in deduction. So you understand that even if we are using deductive logic, but the truth and falsity of the premises will be dependent on some kind of inductions, and therefore there will be a, I will say, uh, there is an overlap of both deduction and induction in their own ways, and that is something which we need to understand properly. But whatever, we have projection, we have prediction, and we have so many other things to carry forward this understanding. Now let us come back to induction and understand that how induction works or how induction follows. Mm, One way of understanding induction is that it is a way through which you provide some kind of hypothesis as well. It is a way of hypothesizing certain things. Like there is a study, and the study is of Alvarez in 1980. They say that a meteoroid has struck the surface of the earth, say around 65 million years ago. And why they say that a meteoroid has hit our earth, and that is also, I guess so, one of the reasons cited for dinosaurs extinction, I guess so. I do not remember it very rightly, but at least they claim that this 65 million years back some meteoroid has hit. And how it is found that this 65 million years before? Because the meteoroid had iridium, and the contents of iridium, which is a very rare gas, I guess so, or the rare, and you can call it anything, uh, is found, is something which is found uh, on earth, and it is dated back to 65 million years ago, and there is no possibility that you will find iridium on earth, suppose, if this is the theory. Or you can take any theory for that matter. Suppose you find something somewhere, if there is an investigation which is going on, if there is a criminal investigation which is going on, and that criminal investigation is saying that okay, if somebody is killed at some place, and somebody has been brutally murdered at some place, and there were two people apart from the person who was murdered inside that house, and we can prove that nobody came from outside and nobody left from inside, so these two people who were present apart from the person who has been murdered, the reason, or they are, one of them or both of them have killed that person or have murdered that person. So those kind of understandings or those kind of things are basically based on induction, and they are based on what we will call as sorry, some kind of hypothesizing, right? That we are having a hypothesis that this is what is going to happen, or this is what is something which is happening. So you can have the name of induction in a lot of ways, like explanatory inference. So this is one way in which people say that or explanatory inference may not be the right word, rather than I will use it as explanatory induction. So this is one way in which people call it, or sometimes they also call it as a some kind of enumeration. So given the enumerated understanding, so they have enumerative or enumeration. I can use this terminology as well, that it is like an enumerative uh, induction. So there are so many terminologies like this. Like there is also a terminology called abduction. This is also a kind of induction, and all these things are basically explaining a concept or trying to generalize or coming out with a result, even if we directly do not have access to it. One of the best expressions which I find for induction is inference to the best explanation, and this encapsulates the understanding properly. Inference to the best inference to the best explanation. So this is also the truth that we have something called inference to the best explanation, because this is also a way through which we hypothesize, or we provide a genuine, or we provide a meaningful, we provide a logical or rational outlook to our observations, right? So whatever be the observations and how the things have been constructed, or how a thing can be constructed at a later stage, are certain things which we use in these kind of explanations. So this induction, this part of induction, is going to be very important. And the other point which I raised before as well, that in no way it is possible for us to actually go through each and every case. Like you might be knowing about the Watson and Crick structure of DNA. So Watson and Crick's structure of DNA, if I write this Watson and Crick structure of DNA, is basically based on Chargaff's rule, right? And Chargaff's rule, I guess so, 1947. So this Chargaff rules 1947 says that in our blood, I guess, or something, there is like C, A, T and G bases, where you will find that the number of these two and the number of these two are more or less I will say found in equal numbers. Now obviously they have not studied each and every of the sample, or in not each and every base of the things. They have definitely conducted studies on some, and they have found that this is the tendency which is found. So they thought that since everybody is like that, so this will have the same kind of understanding in everybody, and it has been found to be true. And on this basis, the Watson and Crick DNA model has come, which is also the right understanding, or which is also the I will say the truth, or this is something also which is applicable, right? So given this understanding, you understand that deduction and induction are very interrelated concepts, and they irrespective of the fact that we say that deduction is non-controversial or less controversial, but what it is based upon is induction, which has a lot of I will say challenges, or lot of stuff which we need to satisfy, or which we need to confirm before things like that. So uh, it is true that if these theories have been established, and these theories are say very strong theories, and they are accepted, and they are say applied, and we have made enterprises on that, but it can falter at some point of the time, because there is absolutely no guarantee that the future will be the replica of the past, right? Or the future will have the same way, the things will behave the same way as it has behaved in the past. In fact, uh, if you understand the concept of mutation, if you also understand that there are certain things which change, so irrespective of the fact that you will find a vaccine for a disease, you never know that you can eradicate that disease, because there is another mutation which is possible, or it has already taken place, and the medicine or the vaccine is not properly acting on the virus or on the bacteria or on whatever you are applying the same way. Moreover, human beings also develop and change, and because of that also the things which were working before may not be the things which may work at a later stage. So those kind of things are also there. Now, why it is important for us to have this idea that why induction and deduction are important for sciences, and how at any point of time induction and deduction can play havoc, or may not be applicable the way it was applicable before. Because induction, deduction, or these kind of understandings, because from the next lecture we will go for confirmation and problems of confirmation, and the same goes for explanatory inferences and so on. Mm, why it is important for us to study these things? Because the basis of sciences, or the basis of all the enterprise which we call as science, is also a very delicate balance, right? And any now and then there can be troubles, or there can be problems associated with it, and we need to figure it out and try to address those problems right from the very beginning. Because this is the way we need to understand, and we also need to work for it, that whatever we consider as, because look, I will like to tell you a few things which has become, or which has been a problem in sciences, right? We usually think that there is an axiom. Axiom, if you understand, is a self-evident principle, right? Then on the basis of axioms we have theorems. So suppose if we have a theorem, then there can be more theorems like this, right? And on the basis of these we can have corollaries or lemmas and so on. We prove, we keep on branching it, and we make it a whole enterprise, a whole way of studying. Now, this is a thing. A corollary or a lemma is based on a theorem, and a theorem is based on an axiom. An axiom is something which is absolutely unquestionable, right? Because it is self-evident. So this self-evident principle, irrespective, and this is what our history has taught us, or the history of science has also taught us, that whatever has been understood as an axiom, or the principles which cannot be questioned, have been questioned at some point of the time. And the geocentric heliocentric understanding to whatever we are studying these days, and how things have changed, like let me give you a very practical example. uh, Say 20 years back, if you get a sprain, right? So, and you have a muscle tear, or you have some pain or something like that. Suppose you got a sprain, you twisted your ankle, or you twisted your knee because of some sporting activity. So it was suggested that you should use hot water, and with that some kind of ailments and some medicines and this and that, to soothe the sprain. Nowadays that concept of hot water has been completely taken over by the understanding that we should always go for ice and the school, say, plasters and so on, all these things which are coming up. Now, I also remember at some point of the time, the doctors used to say that if you have got a burn on your skin, so you should stay away from water. Nowadays, if you are getting a burn, they are saying that first thing you should put as much of water as you can put so that the skin gets a little bit soothed and this and that. Now, the question is not about uh, what which one is the right method or which one is the right way of dealing with things. The more important thing is that it is because of some changes here or here that we have left some kind of therapy and have moved towards another kind of therapy, right? This has been the case. This has been the case right from the very beginning. And do not mind if I'm saying this. The science of today may become a superstition of the future, right? So, whatever we are doing and whatever we are working with, it may not be good enough to sustain. And why it will not be good enough to sustain? Because the pillars on which it is based or where it is placed, we need to keep questioning them. And that is what we will be also reading in the later part of this course, that how we need to develop, how we need to follow the trail, and how we need to make our theories better, right? So whatever we call science or whatever we call technology or whatever we call as superstition may not have been the same, say, before. Sometimes a theory which was a futuristic theory came before, and if it came before, it was completely ridiculed, right? Something which came on time is something which is usually accepted, but whatever comes a little bit before is usually ridiculed, and something which was the science of some point of the time may not be even accepted as a superstition. It can be completely laughed at a later period, even though at some other point of the time again this can be re-established. So the journey of science is not only linear, that there is one development here, then some changes occur, then there is another development here, then some changes occur, and we reach this stage. The journey of science sometimes is also circular. So, and we will discuss the examples of this as well. But the thing which is important for all of us is to understand that how these things are confirmed or on what basis these are used, and how this thing may work in future or may not work in future. So this was it from my side for this lecture. When we will meet in the next lecture, we will discuss about confirmation. So thank you very much for watching.